Hello, and welcome to the Xilinx training on AWS F1 Instance. After this short training, you will understand in detail the technical specifications of the F1 instance. You will learn how the Xilinx FPGA is used and the interface requirements for implementing an RTL kernel on the F1 instance. Let's first look at the AWS F1 instance. The F1 instance is a cloud compute instance which uses a Xilinx FPGA to accelerate the performance of software by implementing the compute-intensive parts of the algorithm in dedicated custom hardware. For this, it uses the Xilinx VU9P 16nm device, which provides over 2 million logic cells, approximately 7,000 DSP engines, and 16 gigabits of memory. This high-capacity, high-performance device allows the acceleration of many software algorithms through hardware. The F1 instance consists of a host CPU augmented with the Xilinx FPGA. The FPGA is connected to the CPU over a PCIe link. The 2x large instance contains a single FPGA and 8 CPU cores. This basic configuration supports up to 48 gigabytes of DDR storage connected directly to the FPGA and transfers speeds up to 10 gigabits per second. The larger 16x large instance configuration uses 8 FPGAs and provides up to 970 gigabits of total system memory, 4 times that in storage. If you look in more detail at the data transfer specification, you can see that up to 30 gigabits per second may be transferred from the host to the FPGA over a Gen 3X 16 PCIe link. Each FPGA connects to 4 banks for DDR, providing 48 gigabits per second transfer rate between the FPGA and the memory. This provides enough bandwidth and processing logic to accelerate any application. Now let's look in more detail at the Xilinx FPGA at the heart of the F1 instance. The F1 instance uses a Xilinx VU9P device. This device, at the leading edge of FPGA design, is a stacked silicon device, meaning it is made from multiple dies connected on the chip via silicon interposers. Each individual die is referred to as a superlogic region, or SLR. The VU9P has 3 SLR regions. Each SLR region has access to 1 or more DDR interfaces. The connections between SLR regions are made across super long lines, or SLLs. These super long lines have longer delays than standard intra-SLR connections. An F1 instance consists of 2 regions, a region called the shell, which cannot be modified, and a region for custom logic, which can be modified to support any user logic. 4 DDR interfaces are available, and the DDR interface in the shell region may be accessed by the custom logic. The shell is loaded at power-up and is always live. It includes the PCIe link and all the hardware necessary to interface with, and provides debug support for the custom logic. The logic in the shell region cannot be modified by the user. The shell logic is clocked at 250 MHz. The shell also includes debug and security features. Looking at the shell debug and security features in more detail, the shell includes hardware firewall logic to ensure that the kernel cannot accidentally halt the operation of the F1 instance, and enables recovery of the instance in the event of a protocol violation. A feature ROM to ensure the F1 instance is only ever loaded with a valid design, one created for this platform. And finally, hardware to ensure the same debug features users have come to expect from Xilinx FPGAs are fully available through their PCIe interface. The custom logic region represents most of the available logic on the FPGA and may be programmed and reprogrammed continuously. multiple kernels may be simultaneously loaded and unloaded into this region throughout the execution of the application. The clock for the custom logic region is specified by the user and may be up to 500 MHz. Clock domain crossing logic is automatically implemented between the shell and the custom logic regions. The kernels are automatically compiled into the FPGA, but as with any FPGA design, the kernel developer has complete control of the implementation details and hence the ability to create very high performance designs through the use of specific synthesis and placement options. When working with custom logic, it is important to understand some of the requirements imposed by the AXI interconnect on the platform. The custom logic region accesses the data through the DDR interfaces. There are 4 DDR interfaces. Each interface is 512 bits wide and can transfer data up to 16 gigabits per second. Each interface may be driven by up to 16 AXI master buses. This implies a maximum of 64 kernels if each kernel only has one AXI master interface, or fewer kernels if some have multiple AXI master interfaces. When you have more than 4 AXI master buses driven by the kernels, care needs to be taken to ensure they optimally share the bandwidth of the DDRs. Now that we understand the device at the heart of the F1 instance, we can already review some of the recommendations for the kernels. When designing on the F1 instance, it's advantageous if the kernels fit inside one SLR. This prevents logic being implemented across super long lines. It's also advantageous if the logic which accesses the data in a particular DDR bank is implemented near that particular DDR interface. These techniques allow the design to more easily and automatically close timing during logic placement and routing. Following recommendations is a good idea. However, even if your kernel violates any and all recommendations, the Xilinx ultra-fast methodology guide shows how even the most challenging designs may be successfully implemented on the VU9P device. To maximize system performance, you really want to ensure you have maximum data transfers and minimize the on-chip congestion. Each DDR is 512 bits wide. Try to transfer data in wide 512-bit words. However, keep in mind each interface can only be driven by a maximum of 16 AXIM buses. Try to share this interface in a manner which does not limit the computation rate, because a transfer from one bus will block the others. If your kernel or kernels have more than 4 data transfer interfaces, consider how they can be mapped into 4 512-bit DDR banks and still have continuous processing. Making maximum use of the DDR interfaces will result in a high-performance system. The AWS F1 Instance is a scalable cloud-based platform for acceleration using FPGAs. Up to 8 Xilinx FPGAs and 64 CPUs may be configured for high-performance processing. The F1 Instance provides a Xilinx FPGA with fixed and customizable regions. The shell logic ensures all connectivity and debug logic has been already implemented for you, but it does place some interface limitations on the custom logic region. Up to 2 clocks and 4 512-bit data transfer interfaces are provided with full control over the RTL implementation. Thank you.